This time I have a Panasonic PVD4744 DVD player and VCR recorder combo. This one is completely dead and it has two problems. First one wasn't too bad to find. Second one took a little bit of thought. Let's check this one out. Check out the process of elimination to get this one solved. I have a Panasonic. This is a DVD player VCR combo that was brought to me to look at. Actually, wasn't brought to me. I was doing some work at the owner's house, and he says, "Hey, I remember you used to work at the TV shop." I said, "Yep, I did." And he says, "I have a VCR. I'd really like to see if you can get it to work." So I said, "Sure." So he brought it to me, and now we're going to take a look at it and see what it's doing and what it's not doing. So let's power it up. I see no power. I see no power to the display. So we may have a power supply problem. Let's crack it open and see. So the power supply is over in this corner. Wonderful. Love these designs. Okay, let's just see. Make sure that I actually do have power. Yep, I do have power on my bench. It is powered up. Besides, I know that because see my battery charger's lit up here, which is plugged into the same outlet. Okay, I guess the first thing I got to do is I got to get the DVD player out of the way so that I can take a look at the power supply and see whether we're getting anything happening whatsoever. At this point, it could be just about anything. It could be a problem with the primary side of the power supply. It could be a problem on the secondary. It could be capacitors. It could be the regulator IC. At this point, I don't know. So we'll remove the DVD deck first so that I can access the board. I've never worked on one of these ones yet. That video drum looks to be, it almost looks like this thing's been wet. Take a look at this. Take a look at the drum. What is that? All over that drum. Yeah. Like that is yeah, that's not good. We'll see whether this one's fixable. At this point it has no power, so this is from 2004. This would have been getting probably close to the end of production of VCRs for Panasonic. I don't know what year they stopped making these things, but I think most VCR, most of the major manufacturers got out of VCRs in the what, mid 2000s. When was the last VCR made? Like, I think Funai made them until like 2015 or something. They were hanging out there for a while, but a lot of the manufacturers actually stopped making them prior to that. But I don't know what year Panasonic actually threw in the towel as far as VCRs and combo units like this go. Just unplug the DVD player and unplug the power here from the DVD player. Get that out of the way. Now we can look at the power supply and see whether there's any life at all. I should see some voltages on the DC side if the oscillator's running. If not, then it's something on the AC side that's gone bad. So let's take a look. Meter on. Okay, power is on. And we'll just look and see if there's any voltages on any of these diodes, for example. 1.9. There's something there. What else do we have on here? Nothing. .4. 2 volts. Oh, 5 volts. So the power supply is running. That's good. You see, our 5-volt supply is there. If I shut off the power, our 5-volt supply will just drain that down and see if it comes back up. Because power's off now, but the capacitor will have to discharge. And then this should go to nothing. I'll just ground this out. Okay, so now we're at 0. When I apply power, does this come back? It does, slowly. Really slowly. Peek under this shield to where the high voltages live. Of course, we have to take the back off it to get the barrier off because they've got this hook on there. So if you pull up on this thing, you're going to break the circuit board. So you actually got to release the back in order to get the back cover off, the barrier off the board, for checking things like even the fuse, which of course is fine because it wouldn't be starting up at all if the fuse was bad. With this useless hook, which is not needed. Now I can check to see that this is actually oscillating. That the transistors here is using a couple transistors on this one. I can now scope this and see whether it's working. Now this is a hot ground, so I'll have to ground it to the neutral side on my scope. And that's why an isolation transformer is very important when you're working on the hot side on these power supplies. But it still could be one of these caps that's bad. I think we got a problem on the secondary side here. For that matter, it could be something downstream. With all this crud that's on this head here, I don't know what it is, whether water's got into here and there's maybe this water damage underneath this thing shorting it out. That I don't know. I guess the first thing to do is to pull the board and the VCR deck from the chassis so that I can see underneath here and I can do some measurements for ESR and stuff. Board's got to come out to do that type of work on this thing, because everything's all on one board. My favorite designs. And yes, I am joking. They're not my favorite design. I hate these designs. Okay, I should lift up now, I think. I was looking to see if there's any other screws I've missed. If the deck will lift up now, it should unplug. Unplug the loading motor. And the whole deck should lift up. Oh, I got one ground wire I gotta take out over here. Let me just take this ground screw out. Okay, tape deck's out now. Now a couple screws to remove the board. Mode switch is right here on this one. We will clean the mode switch while this is apart, for sure. Just those screws, and out comes the board. Now I can make some measurements. One of the things we need to do when we want to measure these transformers and stuff with the output transistors, so we need to create a test point. So I just stick a little bit of solder on there. That way I can clip my scope on and it's not going to come off. I've got my scope grounded to the hot ground. Now, in this case, you need an isolation transformer, because if you don't have an isolation transformer and I flip that power switch, I'm going to blow up my scope. Okay, so you can't do this work without being totally isolated. And I'm talking an isolation transformer that is completely floating. Your neutral cannot be connected to earth. It cannot. And most of the isolation transformers you buy, the neutral is grounded, so they're not really an isolation transformer in the technical terms of isolation for safety. They are a lot of those isolation transformers you buy, they're isolating to isolate noise coming down the power line, but they're not isolating for safety. So there's going to be several hundred volts on this when I fire it up. If we look at with the meter, when I put power to this, like it's going now, if I measure across the rectifier here, we will see that there is 180 volts. 180 volts there. And I'm just going to look at the scope here and see whether I'm getting, where's my measure? There we go, measure that. I'm doing this, I'm using my DSO on this, believe it or not. I want to see what type of pulse we're getting and what frequency it's at. And it looks like it's running at 1 kilohertz, which is not, it should be a lot higher than that. 212 volts peak to peak is what we're seeing here. But this is not expected. Turn the power off. See, as the voltage is starting to drop off. So the oscillator is kind of running, but it's not running properly. This should be a nice square wave. That's what we should have there. That's why the transformer is so slow to start. So something is not right in this power supply at this stage of the game. I'm just going to discharge that capacitor so I don't get zapped. There we go. It's now dead. Well, now it is. Make sure it's totally dead. Okay, so I'm going to take a look at this circuit here. We'll look for some bad connections first of all around the transistors and the oscillator and so forth, and then we'll start looking for bad caps. So the first thing I'm going to do is look for any connections that are bad, like that one there. See that? I'm wiggling the transistor and you can actually see the collector moving. I'm going to resolder this area of the board here. In fact, this whole area of this board looks like crap. Look at this regulator over here. This one here, Q100. See that? I'm going to redo this whole part of the board and we'll see whether anything changes, because I see a lot of really flaky looking connections in here, like tons of them. Tons, and that could be all it is. It's a flaky connection. So let's just deal with that first. And then we'll get a little bit deeper into this thing if that doesn't solve it. I know it's trying to start because I'm getting voltage, but it's just very slow at coming up. Yeah, I know I'm using a very fine tip on this thing. My other tip is shot. I haven't had a chance to go buy a new one just yet. Lead-free solder crap. Let's just measure the transistors here. These are MOSFETs, I believe. Where we got gate? Yeah, these are MOSFETs. Gate, source, and drain. I'm gonna put this one. Yeah, maybe okay. I think they're probably okay. I think if these were to pop, they would blow the fuse. Let's check the diodes on the secondary side. See if there's any diodes that have gone bad, because that will certainly cause a problem. I was reading both directions. 0.1. These are capacitors charging up. So these diodes will measure very low in the forward direction because they're high frequency diodes. Oh, that one's shorted. What diode is that? Is that a Zener? That's a Zener diode. That's a Zener diode that's shorted on this thing. Well, that would certainly cause a problem, wouldn't it? Let's just remove that one. I think it's this one right here. So that Zener was shorted when I tested it in circuit. Let's just test it out of circuit. See if the Zener is shorted. Oh yeah, that Zener diode is dead. That might be the problem. The banding on this is red-black, so 2-0, that should be, I think, a 20-volt Zener. It's probably a crowbar. Let me see if I can find anything that's anywhere close to that value. The power supply may have gone over voltage and this thing shorted. May have had a power surge and caused this thing to lose regulation momentarily, and the voltage spiked and the Zener crowbarred. I found one. This is a 22 volt, but it should be good enough for this. Now what I'm going to do on this is I'm going to turn the variac way down when I start this up. just in case this thing goes supernova. We'll monitor the voltage across that Zener when I power this thing up. So I'm going to clip my clip my meter on here, and we'll monitor the voltage and see whether it spikes. This is probably on the 12 volt line, I'm thinking. Okay, variac down at around 30 odd volts. We'll see what happens. I may have to turn the variac up a bit. There we go. Okay. So it's at 16 volts. Power's off now. Power's back on. 17 volts, that sounds about right. It's a 20 volt Zener. The clock display is lighting on the front here. You can see it. I'm sure you guys can see it. It is lighting. Cool. Let's put this board back in and see if this thing fires up. Before I do that, I will clean this mode switch while I've got this thing apart. Just because it's apart. If I can get it open here without taking it out. There's our switch inside here. It turns around. Oh, it doesn't. It's just these little bumps on here that push these contacts down. Interesting. Okay. A different type of mode switch, but we'll give it a shot of cleaner anyway. Okay. You see the mode switch on here, it's held in place by these plastic clips, because what it does is there's little indentations on here, little cams that push push down the little switches to signal. It's kind of a different type. I've never seen one of those ones before. So just fasten the screws in for the board. At this point, I should be able to turn this thing up to the full power, 120 volts, and fire it up and see whether the deck will actually turn on. So we got power, and it turns on. And if I try to load a tape, will it try to load? No, not yet. it may require the DVD player to be connected before it does anything, because it may be looking for the DVD player. So let's just connect the DVD player and see whether anything happens. Because a lot of these devices, they are dependent on checking ROMs and stuff and checking for a boot up, and if they don't see everything on the circuit, they just don't do anything. Aha! Well, that part works. How about the VCR part? VCR part's still not responding. I think at this point I'm ready to say screw the VCR portion of this unit, just because the shape that this drum is in, I'm not even sure that the heads are going to be any good on it. It's not the mechanism's not operating. I've taken it apart. I've checked out all the connections below, made sure all the plugs are in. They are. Everything's seated properly, but the mechanism doesn't seem to want to do anything. And as you can see, just from all this corrosion all over the head, it looks like it's been wet. I mean, it's all over here. So I don't know if any water got into this thing and shorted something out or what happened to it, but I don't think the guy that owns it wants to spend a heck of a lot of money on it. So I'm going to just put this thing back together at this point and see if the DVD player works on it. If the DVD player works, at least it's better than what we started out with. When we started out with it, it didn't do anything. I can see the people now giving me thumbs down because I didn't finish it, but sometimes you got to walk away from these things, right? Because they're just not worth fixing. But it's still a learning opportunity for troubleshooting that power supply the way that it went bad. So I'm just going to put some screws in this thing and put the DVD player portion back in, and then we'll see if the DVD player works. Of the way they tied these wires up. Just two loops of wires twisted around them. Like that's all snapped on. It is. Let's plug in the AV cable. Power to the TV, power to the unit, open. That part works. I have a DVD plus R. I wonder if it will play a DVD plus R disc. We'll find out. Laser's on. I can see the laser shining here. Yet I don't see any video on the screen. Well, there it is, playing out the component outputs. I got nothing on the composite output. So I would say that we have to check into this further, but it looks like there may be still a power problem. Maybe one of the voltages going to the VCR is missing. And the composite output, the signal goes into the VCR and is switched, and then it goes out the composite output. S-video out on this, and component output is for the DVD player only. Component output looks fine. Picture's perfect. Can't ask for a better picture than that off of the component output. It looks fantastic. But the VCR portion is not working, and there's no video from the DVD through the composite output. So it's gonna. I'm just gonna quickly check for maybe some missing voltages. See if we can figure out what's causing that on this. I say I'm not going to go too far because the guy that owns it doesn't want to spend a lot of money, but if I can get it going, great. But at least we're part way there. We've got the DVD working, we've got it powering up. I just don't have the VCR working. At this point, if you wanted to use it just to play DVDs, he could, using the component output, and it would look pretty good. Let's look and see if we've got any open circuit protectors. IC protectors, they work like a fuse, right? Okay, I've got one here. That one's good. Another one over here. That one's good. Another one over here. And that one's open. Cool. So I think I got a pop circuit protector. What is this one? I don't even know what this one is. What's the value of it? Everything I can find on this, it's listed as a 1 amp circuit protector. I don't have one. I'm not going to get one. I'm going to jumper it with a piece of very, very fine wire. If there is a catastrophic short, it's going to burn this wire up. Besides that, worst case scenario, blow the power supply. Power supply can't put out that much power, and it is fused anyway. So these circuit protectors are a pain in the ass. They are a very fast acting fuse, is what they are. Okay, they're designed to pop before an IC pops, but that generally isn't the case, because generally they either blow as a nuisance or the IC that they're protecting has already popped anyway. So they're just a nuisance. These things fail for no clear reason whatsoever, and they create lots of headaches. So I'm just going to replace this one with a piece of wire across it. Put some solder on here. As they say, this DVD player, or VCR, is probably not going to see much use anyway, because most people are not using VCRs all that much these days, and DVD players. So this is more of a challenge. See if I can get it going. This wire is so fine you can barely see it. There. That is soldered on. Snip off the excess. Measure across the pins. Good. We have continuity now. I'll proceed to put the DVD player back in so we can test the whole thing once it's all back together. For that matter, it may have popped when I fired this thing up without the DVD player in. That may have made it fail, because, as I say, they are so quick acting. The original one, the original part number, is a Panasonic number, and it's discontinued by Panasonic. But there are lots of other ones out there that are the same. But again, it's a nuisance. They cause a lot of nuisance faults. They fail for no reason, and that's why it's not going back in. So it's either going to work or it's not. Let's plug our video into this thing, our video out into it. Power it up and see if I get anything on the screen. I saw a blue screen flash there. And now I have video from the composite output. VCR will probably work this time. Has real fun time reading a DVD plus R. It will read it. There it goes. Now we have composite out. So that part works. Now we'll check the VCR and see whether the VCR works. My guess is that it will. Of course, it's probably not going to work very well with those dirty heads, but it does load the tape. Oh, I don't believe it. It actually plays a picture with those filthy heads. Unbelievable. Let's clean this thing. Let me just get this tape out of here. And you guys thought I probably wasn't going to fix this one, right? Let me clean this thing and see if I can get that crud off the heads. And then we'll put it back together. Actually, I can probably put the front on it now. We know that it works, so might as well put the front cover on. I'm surprised that the heads actually work on this, to tell you the truth.
Is the offer of free second zone speakers, or
but they do, so it still doesn't look very good. It's still dirty as anything. It's all corroded, but you know what? It works. It works. So I'm going to leave it at that, because I think that's as good as I'm going to get this thing. I don't know if this will record from DVD or not. That might be worthwhile trying. Put blank tape in and see if it'll record. It probably won't. Okay, if I press play on the DVD and press record on the VCR, nothing happens. So it does not record. I didn't think it would. Because people would be trying to copy commercial tapes, even though this is not copy protected. Most people bought a DVD player to play back, movies and stuff. This DVD player has the capability of playing DVD RAM discs, which is kind of nice. But it's working. It's got a great picture. That actually looks very nice. That is California Coast. That's one of my productions that I burned onto a DVD just for testing. So I don't have to worry about, well, somebody will probably try to make a copyright claim and say it's theirs. You get some photographer who set up in the same location and did the same type of recording, and he's going to say he owns a copyright to it. But there it is. It's working. The VCR works. The DVD player works. I'm happy. Thanks for watching. We'll catch you in the next one real soon. Bye for now.